All right, the second lecture, we're going to be talking about the difference between, we're going to be talking about something called approximate numbers versus exact numbers. Now, when we say an exact number, what we mean is these would be counting numbers. For example, 10 fingers, 20 people, etc. We are familiar with these numbers because we know what they exactly mean. Counting numbers, these are usually they represent measured quantities. Measured quantity. Okay. Which means things like length, volume, area, temperature, etc. Now, with measured quantity, the value depends on the instrument that you use. Depends on the instrument, right? For example, using one instrument, say instrument 1, you get a measurement of 7.2 centimeters. But then I use a more precise instrument and I get that it is 7.187 centimeters. I can use another instrument which is even better, and maybe it actually is 176.723 centimeter, etc. So the value that is measured depends on the instrument that is being used. That's where approximate numbers differ from exact numbers. Which means that when talking about approximate numbers, we need to introduce a certain terminology. One of the terminologies that we use is called significant digits. Okay, and we are going to learn how to find out how many significant digit or significant digits are in a number. To do that, you have this worksheet number 2, and there are these 5 rules which you can use. All non-zero numbers are significant. Zeros placed between 2 significant digits are significant. Zeros to the right of both decimal point and another significant digits are significant. Zeros at the beginning of a decimal point or before digits are not significant. And zeros used as placeholders are not significant. So for example, if I have the number 74,000, then there are 2 significant digits because these zeros are placeholders, so they are not significant. Okay, switching back, let's see, zeros between 2 significant digits are significant. So if this was 74,001, now it has 5 significant digits because these zeros are between 2 significant digits, which implies they are also significant. Let's switch back. Zeros at the beginning of a decimal point or before other digits are not significant. Okay, what that means is if I have 0.0073, zeros before decimal point, not significant. So this only has 2 significant digits. Okay, now that we have a means of measuring the number of significant digit, we can define two more things. Accuracy, which is the number of significant digits. So it's straight up, it's just counting how many significant digits there are. And we can define a second term called precision, which is the position of the last significant digit. After the decimal point. Which means that if there is no decimal value, then we don't really talk about precision. For example, let's say I have 131.08. Now, the accuracy here, we say, is 5, because that's how many significant digits there are. Each of these digits are significant, including the 0, because it is between two significant digits. This is the last significant digit after the decimal, which implies that the precision we can say is 2, or we can say is hundreds place. Okay, both of these languages are okay to be used. Again, you can refer to the sheet here, which says precision is the decimal position of the last significant digit, whereas accuracy refers to the number of significant digits in the number. Now we use this for the process of rounding off. And this is important because if I have a measurement like 723.854, there are multiple places in which I can round it. I could round it to be 7.12386. I could round it to 7.1239. I could round it to 7.124. I could round it to 7.12. I could round it to 7.1, 7, 10, right? So we need to be clear about where the rounding is being done. Okay, and the language that we use for this purpose is the significant digit, right? We use the position or the precision. Okay, what that means is if I start off with the number 31.8765 and I say round to a precision of hundreds, this means that after rounding, the number should have a precision of 100. So I look at this number 31.8765. Because I need the precision to be hundreds, this is where I'm rounding off. To do that, I look at this next number, right? So if it is greater than or equal to 5, then you increase by 1. If it is less than 5, then it remains the same. And that's greater than 5. So when this is rounded, it would be 81.88, right? Because I increased the previous number, the place where I'm rounding it off, by 1. So given a number, if you're rounding, you need to mention exactly where you're rounding it, because if not, then it's not clear, right? You need to be able to communicate correctly. Okay, next topic is operations on approximate numbers. Let's say I need to add these measurements: 9.08, 11.1, 3.736, and 5.55. Now, the first observation here is they all have different precisions. Okay. Now, well, you would be using a calculator to add, but for this example, let me just do a manual addition. So I get a 6, 8 plus 8, 16 with a carry of 1, 9 plus 5, 14 with a carry of 1, 10, 11, 14, 19 with a carry of 1, 29.466. Now we need a rule. The rule says that for addition, the result has the precision of the least precise number. Now the least precise number here is 11.1, which means this needs to be rounded here, which by our rule, by comparing the value 6, which is more than 5, becomes 29. That's going to be the result. So when you're adding approximate numbers, you got to be careful that the final result that you report has the precision of the least precise number that you added. Again, that's here in the rule. When approximates numbers are added, subtracted, the result is the precision of the least precise number. Similar rule follows for multiplication division. The result is expressed with the accuracy of the least accurate number. So in this case, it's accuracy. When finding the square roots of approximate numbers, the accuracy of the result is the same as the accuracy of the original number. So if your original number has an accuracy of 2, then your square root will also have the accuracy of 2. So this is the second prereq, because we will be working with a lot of physical objects, measurements. You should be able to express the results in a correct, consistent fashion.